Hello, everyone. Welcome to our talk on the road to Jetpack Compose. Or since we've titled this talk back in February, it's more appropriate to call it At Home with Jetpack Compose. I'm Tim Song, a developer programs engineer on the Android DevRel team.
And I'm Sean McQuillan, a developer advocate on the Android DevRel team. And I want to give a call out to the hidden heroes of the talk. My spouse and Tim's spouse are both watching our kids, so we can give this talk without any toddlers interrupting. So good news and bad news there. Back to you, Tim.
Thanks, Sean. So just a heads up, our talk might run a little bit long, and then there's Q&A afterwards. So if you want to grab lunch and join us for Q&A, please do so. All right, let's get into it. So what is Jetpack Compose? So Jetpack Compose is a new UI toolkit for Android. Now, a UI toolkit provides the elements to building your UI, such as a text view or a button. And Jetpack Compose is a new version of that. Jetpack Compose is also a declarative UI toolkit. Now, what does that mean? So Compose is responsible for mapping the state of your application to the UI. Now, here we have the state on the left represented by a list of items, which is then processed by Compose to generate the UI on the right. Now, if the state changes, Compose will figure out what exactly changed and then update the UI accordingly. So if we add one more item to the list, Compose will say, hey, we'll need to update the UI, and then the UI will update accordingly. So why are we building Compose? This is a rather large undertaking, and we have almost 10 years of experience with the current UI toolkit. Users' expectations for UI have changed over the last decade. Now, maybe 10 years ago, it was okay to have a very kind of simple UI. It was a simple layout, and it's okay for a UI to have a bit more latency. But nowadays, users' expectations have changed. They want a high level of polish from your app and very complex UIs comprised of many different elements and different sources of state. Users also want that UI to be very reactive. So when the state changes, they expect the UI to instantly update to reflect those changes. And because there are many state changes, many parts of the UI are updating together in a very reactive way. So an example of that is a social media app, where initially you're looking at maybe a list of posts, but as the app stays open, new posts will come in and the number of likes for a certain post will increase. And this is all done in real time without you refreshing the page, happens every few seconds. So the declarative UI model of Jetpack Compose really helps you build these type of applications with a lot of high complexity and a high level of polish. Where are we in the Compose timeline? So at I/O of last year, we open source Compose. Back then, it was a rather a simple tool. You could basically display text. There were minor support of vector drawables and rows and columns. And so you can build a really nice screen of text. But since then, we've gone through 2 developer previews and are currently in alpha. So right now, Compose offers a very rich set of components, it's very comparable to the current classic UI toolkit. Now, because this is an alpha, APIs are still unstable. We have some refactorings coming up. And of course, there are a lot of UI studies going on that we will make changes in response to that. So know that in Compose and alpha, there's a lot of stuff that's still changing. So Jetpack Compose is a declarative UI toolkit for Android built in Kotlin. And because we're using Kotlin, we can use the full expressive power of the Kotlin API, which you can see examples of that in the slides coming up. All right, let's go ahead and dive into some code and see how we actually add Compose to an app. So here you have a Kotlin function called greeting, and we've added a composable annotation to it so that it can be used by the Compose framework. Inside the greeting, we call the text composable. So basically, composables can call the composables. And in here, we want to pass it the string that we want to display. And because it's a standard Kotlin code, we can add a param and then use that in our text composable. Now, you might be wondering, why are the function names capitalized? Well, the compose convention is to capitalize the objects on the screen, such as text, buttons, and images. And the lowercase functions represent the actions that can modify those composables. Now, let's go ahead and see this used in an Android app. So here we have your activity with their standard onCreate function. You'll notice in here we don't have setContent view with the layout resource. Instead, we use setContent. SetContent takes a given composable and makes it the root view of this particular activity. And in here, we can choose a theme. We'll use material theme. In this case, it has a bunch of cool defaults. And in here, we will call our greeting composable from earlier. Now, if we build and install the app, here's what it looks like on a device or emulator. Now, okay, it runs. The text is a little bit small and it sits towards the left in the top borders. So let's go ahead and add some padding and styling. So for that, let's go back to the text composable from earlier. We can go ahead and add a modifier to add some padding. And then for styling, we can increase the size of the text. In this case, a material theme will give us a bunch of great defaults. So let's use H5. Now, if we build and reinstall the app again, we can see the updated changes. Now let's go ahead and explore how Compose takes an input and makes updates based on those inputs. Now here we have a shopping cart with a couple of items, a mug and a toy. We have the buttons for each particular item that can increase and decrement the quantity, along with some text displaying the quantity of each item, along with the total number of items in the cart. So if we press plus on the mug and toys a couple of times, you'll notice that the quantity increases, and of course the total number of items in the cart quantity also increases. Now let's take a closer look at how these button clicks are mapped to those text fields. So here we have our cart composable, and we can use the greeting composable from earlier. Next, we'll need a way to actually keep track of the quantity of each item. So for that, we'll use the remember function to keep track of state. Now, for these two particular buttons, we'll need to map those to that particular state. So when we click the plus button, we'll increment the value, and when we click the minus button, we'll decrement the value. And in the middle, we actually grab the value of that state and display it. We have a very similar setup for the toys. And at the very bottom, we'll grab the total of those values and display it in the cart. Now, Compose is very great at determining like what actually needs to be updated on the UI. So if I click plus on the mug, only the mug quantity and the total number of items in the cart quantities need to change. Compose knows not to change the text for the toy quantity, and this process is called recomposition. Now, Compose has really great tooling support in Android Studio. So if you want to preview our cart, we can create a function preview and annotate it with the preview annotation with the name of the preview. And if we actually click on, so similar to the XML layout, we can actually preview it as a static view in Android Studio. But the Compose preview is actually interactive. So if we click the button to make it interactive, we can actually interact with this preview directly in Android Studio. So you notice here that we're clicking the item quantity, or changing the item quantity, and we're seeing these results live. Now this is really cool because you don't need to actually build and install the app on your device or emulator and then navigate to a particular activity or screen. You can do this directly in Studio, which will greatly speed up your iteration time to look at your results. So back to the shopping cart. Now, we have state in here, and this might be a code smell. So is this something that we want to do in Compose? Well, we can explore that a little bit more. Sean will talk more about state, and I'll pass it over to him.
Thanks, Tim. So I want to start by talking about why did I want to talk about state today? Compose is a whole UI toolkit. It has a new text system, it has new animations, it has a new layout system, material themes, and a whole material subsystem. And each one of these topics deserves a 40-minute talk all by itself. And I'm sure over the next year we'll see talks on all of those topics. But underlying all of these APIs, at the core of Compose when we designed it, is this coherent state story that we've kind of designed everything around. And so understanding the state story will help you understand the API design of the rest of Compose and how to use Compose effectively to build screens. So to get started, I want to make a really general definition of state. I want to talk with the most general terms and say that state is any value in an application that changes over time. And if you think about this, this is kind of trivially true, and it applies to a broad spectrum of states. It applies to a mutable state of variable, like Tim showed on the previous slide. It applies to a variable inside of a view model, a member variable inside of a view model that you can update, or a room database, for example. It changes over time time, so it's state in your application. It also applies to some other situations you might not think about, like an accelerometer that produces a new acceleration value over time. And all of these things are state. And what I want to do in this talk is kind of scope that down and talk about how do we take that general concept of state and scope it down into something that we can think about and work inside of Compose and use. To do that, I'm going to start with a hybrid application. This is what most people are going to start with for their first Compose application. They'll take an existing Android application comprised of maybe some activities and some fragments, and then they're going to just swap out the UI for a fragment one at a time for the Compose UI toolkit. So when you do that, a screen is going to be comprised of a fragment with the Compose UI toolkit actually drawing the screen. Then we're going to switch gears and talk a little bit about the composition process a little bit more abstractly. What does Compose actually do? And then we're going to talk about recomposition. How does Compose update the screen when the state changes? So the big idea of Compose is that Compose is built for unidirectional data flow. This is kind of a big abstract construct, and if you haven't used it extensively, this might be a little bit scary. So what I want to do is kind of walk into what is unidirectional data flow before I define it. And to do that, I'm going to go and zoom in on just the buttons and the text that Tim was showing in his example. So here I have the minus button and the plus button and the text that displays the quantity. And what I want to have happen is when the user clicks on the button, the text changes. If it goes up, it's going to turn the 3 into a 4. And I'm going to go and build this a couple different ways. So to start off with, I'm going to go back 10 years. I'm going to code this the way I might have coded this in 2010. And a lot of people did code things back in 2010, and we'll talk about how this looks like. So what I'm going to do is I'm going to make a counter activity, and then I'm going to, in that activity, make a private mutable variable, which is just the current count that I'm displaying. Then in my event listeners, in my on-click listener, I'm going to directly mutate that count. I'm going to increment or decrement that count as appropriate. And then I'm going to call a function that I've defined called update count. And what update count is going to do is it's just going to take whatever the current value of count is, and it's going to bind that count to the text field. So this actually works pretty well for this really simple example like this. And when I'm making really simple screens, sometimes I do code in this way. But I found, and a lot of people found, that this doesn't really work as your UI gets more complex, as you add more state and you add more events. So there's two big problems that can happen with this. One is you have, as you introduce multiple pieces of state, the event handlers you actually get from the UI toolkit don't directly map to the event handlers that maybe you want. So I don't, for example, have an on increment event handler here. I have a set on click listener. So it's very easy sometimes to accidentally partially update the state. Maybe update one state variable and you were supposed to update another one, but you forgot to, and this leads to a user-facing bug. Similarly, it's very, very easy when you're programming in this style to update a state and then forget to tell the UI to redraw it. And this is a partial application. So the user is actually going to see stale state until some random time in the future when you rebind the state and it actually displays the correct state. So these two things put together, coupled with the fact there's not really any way to kind of like pull this activity and tease it apart. It's all sitting inside of an activity class, so it tends to get very large and often just kind of intractable. It's very hard to read the code. So these problems are things that caused us to, a couple of years ago, introduce the Android architecture components. And this is a way to kind of structure the same code that helps address these problems. So this isn't going to be an architecture talk that I'm giving today. So I'm going to introduce this differently than I would if I was first introducing view models or live data. What I really want to talk about, this is a little bit of a meta architecture talk. I'm going to talk about the design behind architecture components. What were we trying to do with view model? What were we trying to do with live data? And how did they get their final API shapes? So I want to build that same screen, but now I want to use a view model. So to use a view model, I'm going to have to represent my state. So my state in this activity is a count variable. And I'm going to represent that in a view model using a live data. And so I'm just going to go ahead and declare a live data, and I'm going to point it to immutable live data, which I can update. And then I'm going to define some events here. So I've defined some state and I've defined some events now. And these events, it's common on view models to represent these as member functions that are called directly by the UI. So I'm going to do that on the slides here. So this is an increment event right here. And what an event does is it does some processing, and then it has the choice to update any of the states in the view model if it chooses to. So here, what we're doing is we're grabbing the current value, we're doing processing, we're incrementing it by 1, and then we're setting the count variable to the new value. Similarly, we're going to define an event for decrement. So now I've kind of taken my on-click listener events and I've replaced them with this view model, which defines a single count state and an increment and a decrement event. Now I can take and I can draw a little diagram over on the right here where I put the view model on top and the activity down below. And when I do that, we can actually see that when we think about how this works, the state is always going to flow down from the view model into the activity. And similarly, the events are always going to propagate up from the activity to the view model. And this is the kind of design we want to be aiming for as we go into unidirectional data flow. Okay, so let's go back over to the activity and see how we're going to wire up this view model. So now I'm going to have this view model, and in my on-click listener, instead of directly modifying the state, all I'm going to do is call the appropriate event over on my view model. So in the minus button, I'm going to call decrement, and the plus button, I'm going to call increment. And so I'm going to go ahead and pass my events up to the view model. And similarly, for the state, all I'm going to do is observe that state. So whenever that state variable changes in the view model, I'm going to go ahead and rebind my text over in the activity. So I can run it again, and I can see when I click, the 3 turns into a 4. So what we just did, taking the state and moving it from the activity over to a view model, is an example of state hoisting. And this is a concept that underlines the design of view model and live data. And the concept basically is to take and move state up to make a component stateless. And as we move into Compose, we're going to see this is really core to understanding how to design state interactions in Compose. We'll explore that more as we go through the rest of the talk. So taking a little architecture pause, as I was preparing this talk, I did a quick survey of the entire architecture alphabet to kind of check which ones interact kind of directly with this unidirectional data flow idea. That's specifically where state flows down and events flow up. And we can see that all of the architectures that have grown in popularity over the last few years, MVI, Mavericks, MVVM, Guide to App, Android architecture components, guide to app architecture. So all of these pretty strongly encourage unidirectional data flow, where state is always flowing down and events are always flowing up. Some of the older architectures that we all used maybe a couple years ago, like MVP or MVC, often do have events going down. Now you can use things where events go down in Compose, but you're going to have to build a little bit of bridge codes to turn those events into state. So moving on, let's talk about how Compose, what does Compose consider state? So in Compose, Compose will consider anything state that is an observable value that updates its listeners every time it's changed. There's quite a few things going on in this definition. One of the most important is that it must be observable. So observable really means that there is just some function like .observe or .subscribe that anyone can call on this object to get notified when the object changes. So live data is an example of observable. A state flow is an example of an observable. There's a lot of different observables. You can code them yourself if you want to. But the key idea is that anyone can register for changes on this observable object. Similarly, it represents a value. So that means, similar to our count variable, it represents a value at this point in time, like 3 or 4. And when you update it, it's always going to notify the observers. So it's always going to update its listeners every time it's changed, is super important as well, because Compose basically needs to be notified that the state changed. Otherwise, there's no way for Compose to update the screen and keep your user in sync with the current state. So let's take this view model we just built with unidirectional data flow, and I want to swap that activity out for Compose. Let's see how we can do that. So I'm going to go ahead and use that set content that Tim talked about in the intro, and I'm just going to call into a composable that I'm going to define called cart screen, and I'm going to pass it that view model. This is an appropriate thing to pass to a screen level composable because it's really the view model represents the state for that screen, and the screen level composable interacts with the entire screen. So we're okay here. Then inside of the cart screen composable, I actually want to take that view model apart just a little bit before I pass it down. So I'm going to start by reading the count from the view model. And I'm going to do that with this fairly complex line where I say view model.count, and then I'm going to call observe as state. And then I'm going to take the result of that and I'm going to use by to delegate it to a count variable. So when I look at this line, there's actually quite a bit going on. So let's kind of take it apart, tease it apart, and see what's going on here. So this is equivalent to what we did before, where we said live data.observe. And then if maybe inside of the Lambda body, we put the rest of the function. We put the cart counter composable as the Lambda body for the .observe method. But similar to coroutines, Compose lets us actually kind of restructure our code a little bit here, so we can like actually drop that level of indentation that we add every time we have one of these observe callbacks. So what we're actually doing here is observe as state is a composable function that it observes the live data of t, and it basically converts it into a state of t, which is a observable value type that Compose knows about and is deeply integrated into the Compose runtime. And then it's going to return that out to our cart screen. Then we take that state of t object and we use the by property delegate syntax to go ahead and kind of like treat it as if it's just a regular integer. So at the end of this line of code, what I've done is I've taken a live data of integer and I've converted it into just a regular integer. So count is just a regular integer, which is just whatever the current value of live data is at any point in time. Now I can go ahead and pass that integer down to a cart counter, and I no longer have to interact with live data at all. I'm basically just interacting with regular integers at this point. Similarly, I'm going to go ahead and take two events off of my view model. I have the increment and decrement event, and I'm going to pass those down to cart counter as well. So now I'm going to go down to this cart counter. This is where the meat of the implementation is. And I want to pause here at the very top and look just at that function declaration, because I can learn a lot in Compose by just the function declaration. And as you start learning Compose, I strongly urge you to think about function declarations in total as you start going. So here's what I can see in this function declaration right here. So to start with, I see that it has a capital C cart counter and it returns unit. Because it has a capital C and it returns unit, I know that this is a composable that represents or that displays something on the UI. It displays something that represents a cart counter because that's the naming convention. Similarly, I see that it has a single state variable of count, which is just an integer, and then two events, increment and decrement. So I can kind of like already intuit that on increment is a request to change the count, and on decrement is a request to change the count as well. And this pattern is the core pattern of state hoisting in Compose. So you're going to see this an awful lot as you look at Compose code. Then I can also tell, because I take that state variable of count, that cart counter must display something based on count. It's either going to display the actual count as a text, or maybe it's going to display, I don't know, a list of buttons that's that count long. But it's definitely going to display something based on that count state, because it's passed in as state to this composable. So then if I go into the implementation, I can see that I use that state to display the text in the middle. I can just go ahead and, it's just an integer, so I just put it out to a text right there. And then I have the two events that I just go ahead and pass to the appropriate buttons. On decrement goes to the minus button, and on increment goes to the plus button. Now, if we go back to our unidirectional data flow diagram, we can see we've added another level to our unidirectional data flow, and we've preserved state going down and events going up. And if we run it again, we see when the user clicks on the button, the 3 turns into a 4. So this is kind of the big idea of Compose. We want to kind of think about, as we add more levels of UI, we maintain this unidirectional data flow. We want to have it so that state always flows down and events always flow up. And this allows us to now finally define unidirectional data flow. And I'm going to define it as a design where state flows down and event flows up. And I was very intentional with the word design here instead of architecture. There's big A architectures like what you have with Android architecture components. And those can be unidirectional data flow. But in Compose, we're actually able to use unidirectional data flow in a lot smaller areas. So in the design of a single composable or maybe two composables, you can design for unidirectional data flow just on maybe a fab and its child. So in Compose, unidirectional data flow is kind of ubiquitous, and it applies to very small things all the way up to very large architectures. All right, so now I want to switch gears and answer the question, what is composition? What is a composition and how do I make one? And to answer that question, I just want to trace through what happens when the user runs this screen. What does Compose actually do? So the first thing it does is it has this step called initial composition. And to do that, all it does, it's fairly straightforward. It just calls your composables, and they execute like regular functions, kind of exactly the way that you think that they would. So I'm just going to go ahead and run them, and we can see that the execution runs, and we're going to go ahead and call this cart counter. And then over on the right, you can see the Compose is actually kind of keeping track of which composables you use to describe your screen. And it's actually going to keep track of all of the composables you call to describe your screen during the initial composition. And it's going to store that in a thing called the composition. Then it's going to go ahead and call into the row, and then it adds the button as a child and the text as a child. So it's just keeping track of the composables that get called to describe the screen. Similarly, text here, button, and then text. And then it's done. So at this point, it's finished initial composition, and it's produced this tree structure over on the right, which is all of the composables that you called to describe your screen, which allows us to say what a composition is. It's a description of the UI built by Compose when it executes composables. This is a really useful definition. It was very, very thoroughly reviewed, and it is very accurate. But the way I really think about composition is converting parameters into UI. So what I really want to do in the composition phase is, as I'm thinking, as I'm writing, is I want to take, okay, I have these parameters come in. What's the UI for these parameters? Okay. And now to switch gears a little bit, let's go over to recomposition. Recomposition happens after initial composition, and it's basically the process of running the same composables again with new inputs. Now, to do this, Compose, the primary way that you're going to do recomposition in Compose is using state of T. This is that built-in observable type to Compose, which is an observable value holder that can automatically drive recomposition. So let's go ahead and switch gears. Let's take the entire architecture away. Let's remove that view model, and let's build a cart counter that has internal state. We're going to use remember mutable state of, and let's see how that works, and how that actually drives recomposition. So what happens when this runs is it's going to go ahead and add cart counter to the composition. And then when it uses that remember function, what that does is it actually gives memory to the cart counter composable. So what I'm going to do is I'm going to keep track of, I have room for a single object in this memory that I got from remember. I'm going to keep track of a mutable state of variable. So basically, because I stored a mutable state object, I've actually added state to my composable. So now cart counter is a stateful composable, and its state is this count variable right here. It's stored in the composition at the same place the cart counter got stored in the composition. So you can see that represented over on the right there. Cart counter gained this little count state right there. Then it's going to go ahead and run the rest of it, and it's going to display stuff, and it generates the rest of the tree. So right now we have a pretty complex tree, even though we really only have one composable on the screen. We can actually check to see if unidirectional data flow is preserved just on this single function. So what I can take a look at is, where is the state? The state is in cart counter, and where is it used? It's used in text. And we can say that the cart counter provides the state down to text, and the state is in fact flowing down. Similarly, the events are flowing up from the button to the cart counter. So we can actually see that we've managed to preserve unidirectional data flow inside this single composable, which has this fairly large tree that gets generated by the composition. So one question that I have when I first start working with Compose is like, okay, so what happens when the user actually clicks that button? So they're going to click that, and then what Compose does is it goes ahead and calls your on-click listener. This is the same thing as the on-click listener in the UI toolkit. It's going to run on the main thread. It's just an event listener. It gets dispatched after Compose figures out which button actually got pressed. So it's going to go ahead and run that, and in there, I'm going to increment count. So when I do that, what Compose does is it actually marks count as dirty, because it's the special type mutable state of T. It's going to mark count as dirty, and then it's going to go ahead and stop executing. It doesn't like synchronously redraw the screen or anything like that. It just says, okay, there's a dirty state, count is dirty, and you need to do something to update the screen in order to get count to be undirty. So we'll go back to this composition, which is the description of the UI built by Compose when it executes composables. So now what Compose really needs to do is re-execute some composables with the new state to get a new description of the UI, but it has to kind of figure out which composables to execute. Now, the way it does that is it actually looks for, because it has this dirty count variable, it looks for reads of that count variable. And it turns out we have one right here where we're displaying the text of count. So Compose is actually able to figure that out. And the way it does that is during initial composition or recomposition, when you read that state variable, it actually kept track of all of the places that state variable were read. This kind of happens behind the scenes, so you don't really have to think about it. But that's how fundamentally all of this gets wired together. So this state read is known to Compose, and because of that, Compose can figure out right now cart counter needs to run. Similarly, row needs to run because of the way it's coded, and then text, which actually displays that state. The value of count has changed, is also going to need to run. So we went from 3 to 4 or 0 to 1. We need to rerun text in order to display that new text. And then at this point, Compose is actually done, and it's able to figure out by using a bunch of, basically, it's able to figure out by using a bunch of compilation tricks that the rest of these composables don't need to run. And it's actually okay to skip them because they don't depend on any state that's changed since the last composition. So that's the recomposition process, running the same composables again with new inputs. Now, there's a couple kind of big warnings that I want to give around recomposition with some code that I wrote when I first started with Compose, and a lot of people will probably try to write when they first start with Compose. So recomposition happens possibly every single frame. So this happens a lot in the situation where you're doing an animation. The way the animation APIs work in Compose is you just go ahead and update a variable, and that may actually trigger recomposition literally every single frame. If you, for example, read a scroll position, you're going to be running that recomposition every. Or alternatively, it may actually happen never. So this would happen in a situation where maybe I display some static string into a text composable, or other situations where I've not actually put any dynamic state into my parameters for a composable for the initial composition, and then it never has to run that composable again. So it will be skipped every single time. So you only ever get one recomposition for that composable. So as a result of these two things, it's very important that you should never depend on side effects from recomposition. A side effect is actually just anything that's visible outside of the execution of recomposition. So this is maybe writing to a room database. You shouldn't write to a room database during recomposition. Or maybe a little bit simpler, maybe in a view model, you might try to update a member variable in a view model during recomposition. Both of these are visible outside of that recomposition execution, so they're both considered side effects. So you really want to be very careful to just, in your actual recomposition execution, don't actually change anything that basically anyone else can see. Okay. So this allows us to now segue into state hoisting. How do you hoist state in Compose? And this is going to allow us to finally integrate Compose back into our big architecture. State hoisting, as we talked about, is moving state up to make a component stateless. To motivate state hoisting, I want to take these buttons and I want to extend the screen. I want to add that total of 7, and I want to add 2 different buttons. So let's go ahead and get started and see how we might do that. Let's go to a cart string composable. Let's add a column, and then there we just go ahead and add 2 cart counters. And everything's working great already. Both of these cart counters have state. If I click on either of them, it updates the state appropriately, and everything's going really good. And then I try to add that total, and what do I do? The problem here is cart screen doesn't have access to the states that it needs in order to actually compute that total. So let's go think about ways we might try to solve this. So first thing you might think to do is be like, okay, well, I have count. It's a local variable in cart counter, and I could just return it. I could actually return that variable from this composable function, and then make the return type of this composable function integer. And you can actually run this, and Compose will compile this and run it. But let's take a look at our unidirectional data flow diagram and see what's going on. So what's happening is our state is still held by cart counter, but what we're doing is we're basically passing state up. And this is going to lead to all sorts of situations where you end up with duplicate sources of truths, and it often leads to bugs. So this is why we say that in Compose, composable functions that display UI should always return unit, is so that basically so you don't work yourself into this situation right here. Okay, so let's put that aside and let's see what we want to do. You might have been, if you've been paying attention, you might be thinking, I've been paying attention. What I really want here is an event. So let me add an onCountChanged event to cart counter. So every time recomposition happens, I'm going to call onCountChanged, and I'm going to pass it the current value of count. Now, if you're really paying a lot of attention, you might be immediately noticing onCountChange is a side effect of recomposition. And that's already a pretty big problem with it. And the reason it's a side effect is it's something that's done during recomposition that's visible outside of the recomposition. But the bigger problem with this is we haven't actually changed our unidirectional data flow diagram. Even though we're using an event, since we're triggering it every single time count changed, what we're really doing is we're actually passing state up. And we're going to get into the same situation as before, where it's really easy to introduce duplicated state, and we can get into situations where we have user-facing bugs because of this. So this is not something that we recommend as a coding practice. And the specific thing that's really questionable here is the fact that onCountChanged is past tense. What that means is someone was able to change that, cart counter was able to change that state, and it's informing you of the change after it happened. What we really want to be doing instead of all of this is what we want to do is take that count state and move it up into our parameters. And we can actually do that with the general transform. So for any state variable, we can always replace it with this value update value pair. So here we can say count, which is just an integer now, and then onCountChange, which is a lambda, which takes an integer and returns unit. And you'll notice it's really subtle, but onCountChange changed from past tense to present tense. Not good in English, apparently. So onCountChange is no longer past tense because onCountChange is now a proposal to change count. So let's take a look at a unidirectional data flow diagram for this. And we can see now cart screen or higher is the person who owns count. And we're passing state down into cart counter. And similarly, when an event happens, we're passing events up to cart screen. Now, I want to kind of say that's the general transform, but we don't have to stop there. If there's more appropriate events that describe your composables events, go ahead and use them. So for a cart counter, on increment and on decrement are much more appropriate than on count change. So let's go ahead and make on increment and on decrement, and then swap out the rest of the code for what we started with. All right, so to kind of wrap up, I want to take a look at this local state versus hoisted state thing a little bit. Local state being internal state to compose function, that's the remember mutable state of, or even saved instance state. And then hoisted state is caller managed state that's used by a composable function. So local state is very much a private variable. So if you can think about this as actually equivalent to, on a class, a private var. So it's something that's basically just not shared at all with anyone else in the system. Tests, parents, siblings, no one else gets to see this. And it's very appropriate to use it for maybe something like animation state. Hoisted state, on the other hand, is part of your public API. So your caller both has to interact with it, but also can interact with it. So if your caller basically ever cares about the state, you want to kind of immediately go, oh, okay, time to use hoisted state. That's the way to deal with this situation right here. Local state is non-interceptable. The caller basically has no way to control updates to local state. And this is actually kind of really important if you think about this cart counter that we're doing right now. We might say that you can only have 7 mugs. So to do that, you need to say if the proposed update is greater than 7, reject it. And if we use local state, those buttons kind of manage the state by themselves. So we don't really have any way to reject that state change. On the other hand, hoisted state is kind of trivial to intercept, right? You have to provide a listener in order to actually apply the change. And in there, you could decide, oh, I already have 7 mugs. Let's not add any more. It's also interceptable in another way that's really, really important, which is we can actually not back that by mutable state of at all. We can take it and we can intercept writes to that state. And instead of writing that to memory like we're doing so far, we can actually write that out to a room database, which we might actually want to do for a shopping cart application. And then have the UI that's displayed be the result of an observable query on that room database. So it's completely interceptable, and it allows you kind of a lot of flexibility in where you actually end up storing that state and how you manage changes to it. Local state is and should only be used for implementation details details of a function. And as a result of that, it's basically impossible to test. So it's similar to private vars in a class. You run into all these situations where I have to write all this complicated code to test this private var in a class. You're going to run into that same situation if you try to test local state. And that's why you should really think of it as implementation detail. And you should really use it when it's something that you don't really need to test directly. Hoisted state is, on the other hand, trivial to test, and it's something that's easy for the caller to kind of gain a lot of insight into. Okay, and then local state is not shareable. If your parent or your sibling or your grandparent or a view model or a room database needs to know about the state, it absolutely cannot. Local state is not shareable in any practical way. Hoisted state, on the other hand, is trivially shareable. If your parent needs to know about it, like we have with this cart counter screen, it's very, very easy for the parent to just go ahead and say, oh, cool, I have the state now, it's shared with me. So all of that said, I don't want to make that slide be like avoid internal state at all costs. I want to say it's okay to have internal state. You're going to have it all the time. You're going to have it for animations, just all over the place. You're going to have it for checkboxes, for example. But as you start building full Compose applications, your view models are actually probably going to become internal state of screen level composables. So to kind of wrap up the state section, I want to go back to effective Java and look at this immutable classes thing. So they had a guideline. Classes should be immutable unless there's a very good reason to make them mutable. And I think this advice has stood the test of time incredibly well because it's strong, but not too strong. It says if you have a good reason to make your class mutable, go ahead and do so. And we all do that. I write mutable classes, you write mutable classes, everyone puts some mutable classes somewhere. But if you don't have a good reason, go ahead and prefer to make them immutable. And this has turned out to be a really, really good guidance over the last 20 years. Has that been out for that long? And I wanted to take that up to Compose and say composables should be stateless unless there's a very good reason to make them stateful. So this is very much the same thing. If you have a good reason to make your composable stateful, go ahead and do it. Understand what you're doing. It's awesome. It works that way. It's designed to work that way. But if you don't have a good reason, prefer to make them stateless and kind of prefer to use hoisted state instead. So to kind of conclude this, Compose is built for unidirectional data flow. And this applies both to the very smallest parts of the system, all the way up to the big capital A architectures. That wraps up recomposition. So I'm pass it over to Tim, who's going to talk a little bit about interop and migration.
All right, thank you, Sean. So in our final section, we'll talk about how you can add Compose to your existing app. So for this, we'll look at Sunflower. So Sunflower is one of our open source samples. It's basically a gardening app. So on the left, you have a list of plants, and on the right, you have a detailed page of each particular plant. So it's kind of very simple, like recycler view, plant detail layout. Now, in order to add Compose to your app, you actually don't need to change all the layouts of your app. In fact, you don't actually need to change the entire screen. You can actually migrate your app from the bottom up and migrate each individual UI piece by piece. So for our migration, we'll focus on the bottom portion of the page. And let's go over the architecture very quickly. So Sunflower uses a room database to store all the plant data, which is serviced up to the repository and then to the view model, eventually making its way to the fragment and, of course, the XML. So which parts of the stack do we actually want change to add Compose? So we want to modify the fragment and the layouts. So let's take a look at those portions. So currently, this bottom section of the plant detail page is represented by a nested scroll view. It also contains a constraint layout with a few text views, the name of the plant, the text that shows how often it needs to be watered, and the description of the plant itself. So in order to migrate to Compose, we'll need to replace the constraint layout with a Compose view that will contain all the Compose code. The Compose view allows us to incorporate the Compose UI content in existing view layout, and it can be added to the XML layout like any other view. Okay, let's go back to the fragment now. So we're using data binding here, and so we take that data binding variable from before, and then we take that Compose view that we just created and then call set content of it to define the root of our Compose view. So before, in our shopping cart example, we're using the generic material theme. So now wouldn't it be great if we could actually reuse your existing app's theme? And for that, we can use MDC theme, which is from the Compose theme adapter library. This lets you use your existing theme in a Compose context. So now that we have that, we can build out our plant detail composable, passing in the plant ID of the plant that we want to display. All right, so in this composable, we'll need to actually get a context to fetch the view model. So for that, we have context ambient, which gives us a context that we can use in a composable. We'll pass in that context to our existing utils class to basically fetch the view model factory for the plant detail page. Once we have that factory, we can use it to fetch the plant detail view model and then we use that particular view model to grab the plant live data from the view model. There we go. And then we can observe on that particular live data using observe as state, which basically turns a live data and represents its value as a state. And once the plant is available, once Room does all the calculations and grabs the plant from the database, the state will change, which will trigger a recompose, which then calls plant content. So let's go ahead and take a look at the plant content composable. In our plant content, we'll create 3 additional composables that matches up to the 3 text views from earlier. So we have the plant name composable, plant watering for the plant's watering needs, and finally the plant description composable. Let's go through those one by one. And the plant name composable is pretty straightforward. It's similar to the greeting composable from earlier, where we have a text composable with a bunch of modifiers to maybe center the text and make it a little bit larger. The plant watering composable, we actually need to grab a plural string resource. And so once again, we can use context ambient to get a context, which we can then use to call get resources with the proper quantity strings passing in the particular watering interval so we can get the correct text. And once we have that text, we can pass it to a text composable to display it on the page. And then finally, the plant description. Now, if you scroll down on the screen, on the very end of the description, it also it has an HTML link, which we can click to go to learn more about the plant page. So we need to parse the text to support that HTML link. And for that, we currently use HTML compat in our legacy code. However, while the text composable does support clickable text, it doesn't yet parse annotated string. So because Compose is still under active development, there's a fallback for cases like these. So in this case, we can use Android view binding to call on the classic UI toolkit. So here we can pass it plant detail binding. Plant detail binding is just a simple 1-element layout file, which has a single plant description text view. So once we have that binding object, we can call .text on it to get that particular text view, and then call setText on it, and then feed in the parse text using HTML compat. All right, so that's our Compose migration in a nutshell, and I'll wrap things up. So to recap, Jetpack Compose is a declarative UI toolkit for Android built in Kotlin. Now, again, our timeline, we're currently in alpha, so that means if you want to adopt Compose at this point, be prepared to maintain your app given the changes that may come up in Compose. So we're to give feedback to us, we're currently on the Kotlin Lang Slack, and to learn more about Compose, go to our developer website, developer.android.com/jetpack/compose. In addition to the Slack Kotlin Lang channel, we also have a way to provide feedback. That's goo.gle/compose-feedback. And if you want to learn more about us migrating Sunflower to Compose, go to github.com/android/sunflower. We have a couple of Compose talks coming up. One is how the developer community is shaping Jetpack Compose. And then after that, there is a Jetpack Compose panel. All right, so thank you for coming to our talk, and we'll pass it over and answer your questions on the Q&A.
The silence is exciting.
All right, I'll go ahead and read the first question. All right, if you have a complex view, isn't your view constructor going to have a super long list of states and events?
Yeah, so This is a great question, and this is totally something that comes up when you first start building like complex things with Compose. So the basic idea is if you have a single composable that's responsible for a whole lot of things, then you're going to have to pass a lot of different states and a lot of different events in order to handle all of the whole lot of things. So I would say that both this is preferable. That is actually a complex UI component, and you're kind of actually specifying all of the parameters for it. There's a couple ways to alleviate this, though. Most likely, if you have a single composable that's responsible for a whole lot of things, it's actually responsible for more than one thing. And there's ways to kind of to deconstruct this as you get into a little bit beyond 101 compose usage. One of the most powerful is to pass a slot variable. So instead of passing a bunch of states and a bunch of events to describe some portion, maybe there's some fancy button as part of this composable. Instead, you can make a single composable lambda, which is your fancy button slot. So instead of then passing like 6 parameters and 7 events for this fancy button that handles gestures and all this stuff, instead you're just going to specify a single composable lambda, which then handles all of that over at the caller's side. So it actually collapses down those state and events down to a single composable parameter, which then you can later put in the correct place in your layout for this complex element. So I would say that when you first hit this, the first thing you should look at is like, is my composable actually doing multiple composables work? And let me think about using a slot to pass in parts of the UI pre-configured with all of the state and events already handled for that smaller section. That's the most common mitigation for this, and it's definitely it's a pattern that once you see it, you're like, oh, this is clever. This solves my problem really, really well. But if you don't see it, you kind of like you're stuck in this, oh, I have a lot of state and events situation. The other thing I would say I urge you to prefer and compose on composables to pass in kind of immutable classes. So you might want to try to pass strings as states instead of like view models. But as you start building like really complex composables like an entire toolbar, you might consider actually making a complex state object. So you're not actually limited to just passing single properties. If all of your states are related to each other, you can kind of put those together into a class and then pass an instance of that class instead. And that can actually help alleviate some of the parameters as well. But yeah, so backing up, like the big advice, split your composable up. If it's a big complex composable, it's probably multiple smaller composables. And then if they are actually really tightly related together, using object-oriented programming to couple together a bunch of different states is a really good pattern as well.
All right. Next question. Can a composable component like cart counter be used within an activity or XML, replacing custom view components?
So in practice, like I'm not sure I fully understand the question, but let me take a stab at it. So what I kind of hear is like, does this replace custom views? And the answer is yes. In Compose, everything is a custom view. If you kind of like made an analogous example from the current system, starting from the screen composable, that's actually going to behave similarly to the way you would if you were writing a custom view, all the way down to the cart counter or even the text composable, because you're able to control the state and the events that are going to each one of these. It's like you defined a custom view with those state inputs and those event outputs. So each one of those things operates kind of in the same space as if you define a custom view, but instead of having to do all the work of defining a custom view, you just make a composable function. When you so Tim's example where he showed how to set just a portion of the screen to compose is as an example of how you might integrate this to a smaller portion of the screen than the entire screen takeover. So you can totally do that as well.
Okay. So the question after that is there a way to expose our own custom views in Compose?
Oh, good. I'm done presenting. I can look at the screen now. Okay. Is there a way to? Yeah. So the view interaction stuff. So Compose has bidirectional interop with views. So you can call views from Compose, and deep down, all of our views that we ship in the toolkit are just custom views. So you can call your custom views as well if you have your own in your own source code. And then similarly, like from a view, you can have you can then host composable code inside of a view. So you can do interop both ways between the view system and Compose, and that applies to custom views as well.
Okay. Does Compose support or will support low-level graphics like painting pixels on a canvas, or is it supposed to be a higher abstraction layer?
Yeah, so Compose has a canvas widget. So Compose, we talked about kind of the UI element composables in this talk, which are things like text. There's also like a layout and then a drawing that happens as well. So Compose does drawing as well, and you can go ahead and grab the canvas composable and do just canvas operations. You've actually seen a lot of really, really cool animations come out on Twitter that basically just use the Compose animation APIs and all of the Compose state stuff, which actually make like it's really easy to make declarative animations. So we've been seeing some really, really cool animations, and I hope we see more of those because I love the animations I'm seeing on Twitter.
All right. And I think this is our last question. How can I apply a common style to multiple composables? So similarly to the shopping cart example and the sunflower example, you can actually use something like MDC theme. So every time you use that, it will actually just use the theme from material or the current theme of your app. So you can just declare that and basically reuse the theme in multiple composables wherever you need that particular theme. And of course, within the theme itself, you can kind of customize your particular composables to be kind of a one-off differentiation as well.
Mm-hmm. I would add to that, like if you had a fancy button style in XML, the representation of that in Compose is fancy button composable. So if you had like some one-off style, that's a one-off composable. How do you manage different configurations in Compose? For example, landscape, portrait, tablets, etc. So we don't have like this resource branching like we had in XML for better or worse. So we don't have this concept of you load like different things. But what you can do is you can just go ahead and figure out what size the screen is. If you do want to branch your layout, for example, off of screen size, you can just ask what size the screen is, and then you could call different composables or the same composable with different configuration options based on the width of the screen. So you actually end up with a lot more flexibility than just switching between XML as well. Because you're kind of in control of this process, now you can do more fun things like, for example, animate between your layout in the portrait mode and the landscape mode. So you can actually, you have a lot more like fidelity over the process by taking control of it in your own code.
All right.
Tim, do you have anything for that?
No, that covered. That's a pretty good description.
I think we did common style multiple composables. Yeah.
Yeah, I think we already did this question. Okay. I think that is all of the questions. We also have the panel coming up soon. So if you have a question that you want to ask, there's still an opportunity to do so.
And I definitely recommend Preeti and Chris's talk as well to learn more about how we've been doing user research to figure out what Compose APIs work. So definitely check that out. And thanks for coming to our talk.
All right, thank you.